What if something were watching us from the darkest void of the universe, and we were only just beginning to realize it? Stay until the end, because what you are about to hear tonight could forever change the way you look at the starry sky. This story begins with a tiny point of light, captured by the telescopes of Hawaii, and ends with a question that science still cannot answer.
Good evening, dear audience. Felipe Suarez here, accompanying you as always on this journey through the cosmos. And let me tell you something before we begin. When I started reading about this object, I felt a chill, not from fear, but from wonder. Have you ever felt like the universe is winking at you? Well, that is exactly what this interstellar visitor seems to be doing. Are you ready to dive into one of the greatest mysteries of our times?
To understand the magnitude of what is happening out there in the frozen immensity of deep space, we need to go back a bit in time. We need to imagine an ordinary night in late 2024, when astronomers from the Atlas surveillance system, that electronic eye that sweeps the skies searching for cosmic threats, detected something that did not fit in any known catalogue. A point of light was moving in a strange way, too fast, too inclined with respect to the plane where the planets orbit. The scientists reviewed the data over and over again, thinking it was an instrumental error, some interference, anything but what it really was. But the numbers did not lie. That bright little spot came from outside, from very, very far away, from beyond the confines of the solar system, from those regions where the sun is just another star among millions. And when the calculations of its hyperbolic trajectory were confirmed, the astronomical world held its breath. They had found the third interstellar visitor in recorded history, and they baptized it with a name that now resonates in every observatory on the planet, 3I/Atlas. The first was Oumuamua, that elongated reddish object that crossed our cosmic neighborhood in 2017, leaving behind more questions than answers. The second was Comet Borisov, an icy traveler that at least behaved as a decent comet should. But this third one, this newcomer, seems to have set out to break all the rules of the game. From the moment of its detection, 3I/Atlas began to exhibit behaviors that defied conventional explanations. Its brightness fluctuated in erratic ways. Its chemical composition showed disturbing anomalies, and its trajectory, that elegant curve that should follow the immutable laws of gravity, presented deviations that no one could justify with the traditional tools of celestial mechanics. Astrophysicists from around the world began to observe it with a mixture of fascination and bewilderment. Each new piece of data arriving from the telescopes seemed to add another piece to a puzzle whose final image was becoming increasingly difficult to imagine.
And this is where things get truly interesting, my friends, because you see, in science there is something we call statistical coincidences. These are those chance events that sometimes occur and which, although they surprise us, can be explained by randomness. But what happens when coincidences pile up? What happens when each new observation adds another improbability to the list? At what point do we stop talking about luck and start suspecting there is something more behind it?
To understand the most recent anomaly, the one that has scientists scratching their heads with genuine perplexity, we need to delve a bit into the fundamentals of orbital mechanics. We need to talk about invisible spheres, gravitational boundaries, those subtle limits where the domain of one celestial body ends and another begins. Imagine for a moment that each planet in the solar system is surrounded by an invisible bubble, a region of space where its gravity is the dominant force, where its attraction beats the pull of the sun. Scientists call this zone the Hill sphere, in honor of the American astronomer George William Hill, who developed the mathematics necessary to calculate its dimensions. Within this sphere, a planet can maintain moons in stable orbits. It can capture objects that pass close enough and slow enough. It is, in a sense, its gravitational territory, its small kingdom within the immense solar republic. And in the case of Jupiter, the gas giant, this sphere is truly colossal. With a mass that exceeds that of all other planets combined, Jupiter extends its gravitational influence to distances that defy terrestrial imagination. Its hill sphere expands for tens of millions of kilometers in all directions, creating a region of space where its 60-some moons dance in orbits that have remained stable for billions of years. And here is where the story of 3I/Atlas takes a truly extraordinary turn. Astrophysicists at Harvard University, using data collected from more than 230 observatories distributed across the planet, have calculated with millimetric precision the future trajectory of our interstellar visitor. They have traced its path through the solar system, projecting its position day by day, month by month, until arriving at a specific date, March 16th, 2026. On that day, according to the mathematical models, 3I/Atlas will reach its point of closest approach to Jupiter. It will pass grazing, in cosmic terms, the boundary of the gas giant's gravitational domain, and the distance at which it will do so is what has scientists truly baffled. The radius of Jupiter's hill sphere, calculated for that precise moment, will be exactly 53.502 million kilometers, and the minimum distance between the interstellar visitor and the planet will be 53.445 million kilometers. The difference between both figures is barely 57,000 kilometers. On a scale where distances of tens of millions of kilometers are handled, that discrepancy represents a precision of approximately 1,000th. It is as if someone had aimed an arrow from another galaxy and hit exactly on the edge of an invisible target, with a precision that defies any explanation based on chance.
Do you realize what this means? Think about it for a moment. We are talking about an object that comes from the depths of interstellar space, from regions so remote that light takes years to cross them. And this object, this solitary traveler, is going to pass exactly through the limit of Jupiter's capture zone. Coincidence, or something more? I do not have the answer, but I confess that the question keeps me up at night.
But the coincidence does not end there. In fact, it barely begins. Because there is something astronomers observed during the passage of 3I/Atlas through perihelion, that point of its orbit where it was closest to the Sun. Something that should not have happened according to known laws of physics. Something that, in retrospect, seems to have been the crucial ingredient that made this impossible precision possible. When the interstellar visitor approached our star, it experienced an acceleration that could not be explained solely by the Sun's gravity. Something pushed it. Something gave it an additional impulse that modified its trajectory by a small but significant amount, approximately 0.1 million kilometers. This non-gravitational acceleration, as scientists call it, is a known phenomenon in comets. When the ice on their surface sublimates from the Sun's heat, the jets of gas that escape act like small engines, pushing the comet in directions that pure gravity cannot predict. But in the case of 3I/Atlas, the magnitude and direction of this acceleration turned out to be exactly what was needed to place the object on its current trajectory. Without that mysterious push, the visitor would have passed too far from Jupiter. It would have continued on without even approaching the boundary of the hill sphere. It was precisely that course correction, occurring at the exact moment and with the precise intensity, that made possible the close encounter that will occur in March of 2026. Mathematicians have calculated the probabilities. Professor Avi Loeb of Harvard, one of the most respected astrophysicists in the world, and also one of the most willing to consider unconventional hypotheses, took the trouble to do the numbers. And the numbers are chilling. The probability that a random course correction would produce such a precise approach is approximately 1 in 26,000. To put this in perspective, it is more likely that you will be struck by lightning at some point in your life, with a probability of 1 in 15,300, than the fact that 3I/Atlas made this maneuver by pure chance. It is like drawing the exact card you need from a deck of 26,000 cards on the first try. It is like guessing a number between 1 and 26,000 on the first attempt. It is, statistically speaking, almost impossible. And yet, there is the object, following a trajectory that will take it exactly to the edge of the gravitational territory of the largest planet in the solar system.
Now then, I want you to stop for a moment and think about this. If you were an advanced civilization come from the stars and you wanted to explore a foreign solar system, what would you do? Where would you go first? Would it not be logical to start with the largest planet? The one with the most moons? The one that offers the most possibilities of finding something interesting? Does it not seem to you that Jupiter would be the perfect place to establish an observation base?
The hypothesis sounds like science fiction. It sounds like the movies we watched as children, those stories of spaceships and close encounters of the third kind. And yet, there are serious scientists, researchers with impeccable credentials, who are beginning to consider the possibility that 3I/Atlas is not a simple interstellar comet. If this object had the mission of deploying probes in Jupiter's orbit, these researchers say, it could not have chosen a better moment, a better place, or a better distance. The precision of its trajectory is exactly what a perfectly planned reconnaissance mission would need. And there is more. There are concrete physical reasons why passing by the edge of the Hill sphere would make sense for someone who wanted to leave something orbiting the gas giant. You see, the relative velocity between 3I/Atlas and Jupiter at the moment of the encounter will be approximately 65.9 kilometers per second. It is a tremendous speed, almost impossible to match with current human technology. Any object that tried to remain orbiting Jupiter at that speed would need to brake brutally, expending immense amounts of energy. But here comes the fascinating detail. Once inside the Hill sphere, the rules change. The velocity needed to overcome in order to be gravitationally captured no longer depends on the original entry velocity, but on the second cosmic velocity of Jupiter at that specific distance. And that velocity, at the edge of the Hill sphere, is only 2.2 kilometers per second. The difference is abysmal, going from needing to brake 65 kilometers per second to only needing to brake 2 kilometers per second reduces the difficulty of the maneuver by a factor of more than 30. If someone wanted to release reconnaissance devices in the vicinity of Jupiter, doing it right at the edge of the Hill sphere would be the optimal strategy. It would be, so to speak, the perfect place to park.
And here arises the inevitable question, right? If 3I/Atlas really left something orbiting Jupiter, could we detect it? Do we have the eyes necessary to see something like that? Well, it turns out we do. Right there, orbiting around the gas giant, is NASA's Juno probe. And if something appears that we did not send, Juno could see it. Can you imagine that moment? Can you imagine the headline in the newspapers?
The idea is dizzying. The possibility that an extraterrestrial intelligence is more interested in Jupiter than in Earth constitutes a sort of cosmic humiliation. For centuries, humanity has considered itself the center of the universe, the pinnacle of creation, the main objective of any visitor who came from the stars. But what if we were not so special? What if, for an advanced civilization, Jupiter turned out to be more interesting than our little blue world? After all, the gas giant has more mass, more moons, more chemical diversity, more potential to harbor life in the subterranean oceans of Europa or Enceladus. Perhaps in the grand scheme of things, Earth is simply the neighbor down the street, the house next door to the place where interesting things really happen. This possibility, as uncomfortable as it may be for the human ego, is being considered by renowned researchers. Not as a certainty, of course, not as a proven fact, but as a hypothesis that deserves to be evaluated with the same seriousness as any other explanation. Because the list of anomalies that 3I/Atlas presents is already too long to be ignored, too consistent to be attributed to chance, too strange to fit comfortably into the category of ordinary interstellar comet. Let us review that list, point by point, as a detective would examine the evidence in a case that defies all conventional explanation.
Did you know that each anomaly has its own probability of occurring, and that when you multiply those probabilities, the final number becomes smaller and smaller, more and more improbable? It is like flipping a coin and getting heads. That can happen. But if it comes up heads 10 times in a row, you start to suspect the coin is rigged, and with 3I/Atlas, we have already had many heads in a row.
The most striking anomaly, the one we have been discussing, is that almost perfect coincidence between the point of closest approach and the radius of Jupiter's Hill sphere. A coincidence with a probability of chance of approximately 1 in 26,000, which was only possible thanks to a course correction that occurred at the precise moment. But there is more, much more. The trajectory of 3I/Atlas is calculated with astonishing precision. The object will pass tens of millions of kilometers from Mars, Venus, and Jupiter on a route that seems designed to maximize the information obtainable from multiple planets during a single flyby. And yet, this convenient trajectory had a peculiar side effect. During the critical phase of perihelion, when the object was closest to the Sun, and any correction maneuver would have maximum effect, 3I/Atlas was practically invisible from Earth. The brightness of the Sun hid it from our telescopes just at the moment when it would have been most important to observe it. It is as if someone had planned the trajectory to take advantage of that blind spot, to make adjustments without being seen. The nucleus of the object also presents unusual characteristics. Polarimetry data suggests that it is abnormally massive for an interstellar comet. Its density does not match what we would expect from an aggregate of ice and dust formed in the confines of some distant stellar system. It seems denser, more compact, more solid than it should be. And then there is the chemical composition of the coma, that cloud of gas and dust that surrounds the nucleus when it is heated by solar radiation. The spectra reveal an abundance of nickel in relation to iron that is unprecedented in any known comet, a proportion that is more reminiscent of industrial alloys than the natural mixture of elements that form in the molecular clouds where stars are born. The polarization of light reflected by the object is also not normal. It presents a profile that does not match that of typical comets, suggesting a surface with unusual optical characteristics, perhaps a structure or composition we have not seen before.
And there is something else that has me intrigued, friends. Something that seems taken from a science fiction novel. The direction from which 3I/Atlas came coincides with the area of the sky from which the famous WOW signal was detected almost 50 years ago. Do you remember it? That radio signal we could never explain. That seemed artificial, that never repeated. Coincidence or something more?
The WOW signal was captured on August 15th, 1977 by the Big Ear radio telescope at Ohio State University. It lasted 72 seconds. It had all the characteristics of an artificial transmission: narrow band, stable frequency, intensity that varied exactly as it should vary if the source were at a great distance and Earth's rotation was slowly sweeping across it. The astronomer Jerry Amon, who analyzed the data, was so astonished that he wrote the word "wow" in the margin of the printout. The name stuck for history. A satisfactory explanation was never found. The signal never repeated, despite decades of searching. And now, almost half a century later, an interstellar object arrives at our solar system from that same general direction of the sky. It could be coincidence. It could be that the universe, with its inconceivable immensity, simply plays these kinds of statistical jokes from time to time. But when you add this coincidence to all the others, the pattern begins to suggest itself. The low amount of water in the composition of the object is also disconcerting. Comets are, fundamentally, dirty snowballs. Frozen water constitutes most of their mass, but 3I/Atlas seems to have much less water than expected, which suggests either a very different origin from known comets or a composition that does not resemble anything we have studied before. The brightness changes of the object are equally strange. Rapid and intense fluctuations that are not easily explained by the rotation of an irregular nucleus. It is as if something inside the object were changing, as if there were active processes affecting the amount of light it reflects toward us. And finally, there are the jets, those streams of gas that escape from the nucleus, and which should be the result of the sublimation of ice by solar heat. But the jets of 3I/Atlas are different. They are more directional, more stable, more powerful than would be expected for an object of its size. Their behavior does not fit well with conventional cometary outgassing models.
Now, I want to be very clear with you. I am not saying that 3I/Atlas is an alien spacecraft. Science does not work that way. Science requires proofs, evidence, data that can be independently verified. But what I'm saying is that this object deserves our attention. It deserves that we study it with all available resources. It deserves that we keep our minds open to all possibilities, however improbable they may seem.
The scientific community is divided. On one side, there are researchers who prefer conservative explanations, who look for natural phenomena that can account for the observed anomalies. On the other side, there are those who, like Professor Loeb, argue that dismissing outright the possibility of a technological origin would be a methodological error as serious as accepting it without proof. The scientific method does not discriminate between hypotheses based on how comfortable or uncomfortable they may be. All explanations must be evaluated with the same rigor, subjected to the same tests, accepted or rejected solely on the basis of evidence. And the evidence, in the case of 3I/Atlas, continues to accumulate. One of the most recent observations adds another level of complexity to the story, and it has to do with the Sun. In late October and early November of 2024, when the interstellar visitor was approaching its point of closest proximity to our star, the Sun was particularly active. A series of solar flares, some of them of class X, the most powerful category, launched clouds of plasma into space at speeds of thousands of kilometers per second. Scientists at the Space Research Institute of Russia have suggested that these eruptions could explain the mysterious non-gravitational acceleration experienced by 3I/Atlas. The impact of solar plasma, they argue, could have altered the dynamics of the comet's tail, modifying the way gases evaporate and creating an additional propulsion that diverted the object's trajectory. Between October 23rd and 27th, according to observations, the interstellar visitor must have received at least 5 significant solar injections. The most powerful probably occurred on October 24th as a result of a Class X flare that had erupted on the far side of the Sun 2 days earlier.
Do you realize what this implies? The Sun, our star, bombarded 3I/Atlas with plasma at 1 million degrees Celsius, and the object not only survived, but used that impulse to correct its course. It is as if someone had harnessed the energy of solar storms to navigate. Does that not seem incredible to you? Does it not seem almost too perfect?
But the story of the confrontation between the Sun and the interstellar visitor did not end there. In fact, what happened next was even more extraordinary. On the night of November 20th, 2024, our star released a solar prominence of colossal proportions. A mass of incandescent plasma separated from the solar corona and shot out into space at vertiginous speeds. And the direction of that ejection was not random. It pointed directly towards 3I/Atlas, which at that moment was moving away from the Sun after having completed its passage through perihelion. The following day, Friday, November 21st, the wave of plasma reached the interstellar object. Data from the Lickey Solar Astronomy Laboratory reveals that this prominence was exceptional. At the moment of separating from the Sun, it had a size greater than 1 million kilometers, more than 80 times the diameter of Earth. A phenomenon of this magnitude had not been observed since the legendary ejection of 1946, informally known as Big Daddy. Astronomers held their breath. They had seen comets destroyed by much less intense solar impacts. Objects that were 2 or 3 times farther from the Sun than 3I/Atlas had fragmented and evaporated before lesser storms. A normal ice body, many thought, could not survive such an onslaught. And yet, 3I/Atlas kept going.
This is what impresses me most about this whole story. The Sun hurled its worst against this object. Flares, coronal mass ejections, gigantic prominences. And the visitor endured, it survived, it continues traveling toward Jupiter as if nothing had happened. What kind of material resists something like that? What kind of structure can withstand temperatures of millions of degrees and keep functioning?
The survival of 3I/Atlas against the solar onslaught adds another piece to the puzzle. If it were an ordinary comet, an aggregate of ice and dust, like those we have studied for centuries, the odds of it surviving intact would be minimal. The extreme heat of the plasma would have evaporated the surface ice within hours. The internal structure, weakened, would have yielded to thermal stresses. The object would have fragmented, dispersing into a cloud of debris that would gradually dissipate into the void. But that did not happen. 3I/Atlas emerged from the storm, apparently unscathed, continuing its journey toward the outer solar system with the same relentless determination with which it had entered. Some researchers have begun to use a provocative metaphor to describe what they observed. They speak of the sun's immune system, as if our star had somehow detected the presence of a foreign body and had tried to destroy it. It is a metaphor, of course. The sun has no consciousness, no intention, does not discriminate between friend and enemy objects. Solar flares are natural phenomena that occur regardless of what is nearby. The coincidence that 3 massive ejections pointed toward 3I/Atlas is probably just that, coincidence. And yet the image is poetic, the solar system defending itself against an intruder, the mother star protecting her planetary children from a visitor whose intentions we do not know. Because the truth is, we do not know what 3I/Atlas is. We do not know where it really comes from, beyond a general direction in the sky. We do not know what drives it, what guides it, what objective it pursues, if it pursues any. We only know that it is here, that it is heading toward Jupiter, and that its behavior does not fit any known mold.
And what comes next? What can we do here on Earth while this mystery unfolds up there in the darkness of space? The answer is simple. Observe, record, analyze every piece of data we can obtain. Because if there is something extraordinary happening, if we are witnessing something that will forever change our understanding of the universe, we want to make sure we do not miss a single detail.
Telescopes around the world continue to point toward 3I/Atlas. Every clear night, when conditions permit, observatories collect new data, light spectra, brightness measurements, position calculations. Each fragment of information is added to the file that humanity is building on this enigmatic visitor. Spectroscopic analysis of the jets will be particularly crucial in the coming months. If the streams of gas escaping from the nucleus contain the same elements we would see in a normal comet, water ice sublimating, carbon dioxide, carbon monoxide, silicate dust, then the conventional explanation will gain ground. But if the spectra reveals something different, something we do not expect to see in a natural object, then alternative hypotheses will gain strength. The chemical composition of those jets could be the definitive proof. It could tell us whether we are facing an eccentric but natural comet or something completely different, something manufactured. Meanwhile, the Juno probe continues orbiting Jupiter. Its instruments are designed to study the gas giant, but they are also capable of detecting objects in its vicinity. If 3I/Atlas left something in the planet's orbit, if it really deposited probes or reconnaissance devices when passing by the edge of the Hill sphere, Juno could find them. It would be the most important discovery in human history. Confirmation that we are not alone in the universe. Proof that there are intelligences out there, traveling among the stars, exploring foreign solar systems with technology we can barely imagine. Or it could be nothing. It could be that 3I/Atlas is exactly what it appears to be at first glance. A rare comet, formed under unusual conditions in some remote corner of the galaxy, that by chance arrived in our cosmic neighborhood, and by chance exhibits behaviors we do not yet understand. Science cannot yet distinguish between these possibilities. It can only continue collecting data, analyzing observations, refining models. The final verdict will come when it comes, and not before.
You know, there is something beautiful in not knowing. There is something exciting about standing at the edge of mystery, looking into the darkness, wondering what is on the other side. Our ancestors looked at the stars and asked themselves the same questions we ask ourselves. Is there anyone else out there? Are we alone? And now, for the first time in history, we have the tools to seek real answers. Does that not seem wonderful to you?
The story of 3I/Atlas is far from over. The object will continue its journey through the solar system for months, perhaps years. It will pass near Jupiter in March of 2026, in that close encounter so precisely calculated. Then, it will continue moving away, plunging once again into the depths of interstellar space, taking its secrets with it. If we fail to decipher those secrets before it leaves, perhaps we never will. Perhaps this visitor will be like Oumuamua before it, an enigma that humanity will contemplate for generations, wondering what it really was, where it came from, what its passage through our little corner of the cosmos meant. Or perhaps, in the coming months, we will obtain the definitive answer. Perhaps some telescope will capture the revealing spectrum, or some instrument will detect the unmistakable signal, or some observer will notice the crucial detail that has so far gone unnoticed. Science advances like this, stumbling with unexpected discoveries that arrive when least expected. History teaches us that the most important advances occur when researchers dare to question the established, to consider possibilities that seem absurd, to follow the data wherever it leads without caring how uncomfortable the conclusion may be. 3I/Atlas is testing us. It is challenging our categories, our expectations, our prejudices about what is possible and what is not. It is asking us, implicitly but insistently, whether we are prepared to face a reality that could be very different from what we have always assumed.
And that leads me to a question for you, dear audience, a personal question, if you will allow me. If tomorrow we woke up to the news that 3I/Atlas is, in fact, an artifact from another civilization, how would you feel? Would you be afraid? Excited? Both? Think about it for a moment, because that answer says a lot about who we are as a species.
There are those who argue that humanity is not prepared for contact, not even for confirmation that there are others out there. That our society, fragmented and conflicted as it is, could not handle a revelation of that magnitude. That the political, religious, philosophical consequences would be too profound to assimilate without trauma. Others think the opposite. They believe that discovering we are not alone would be the most unifying event in human history. That faced with evidence of another intelligence, our petty differences would pale. That we would finally understand that we are one species, inhabiting one rock, in a universe immeasurably vaster and more populated than we ever imagined. No one knows which of these visions is correct. No one can predict how humanity would react to the most important news in its history. We can only wait, observe, and prepare ourselves as best we can for any outcome. Meanwhile, 3I/Atlas continues on its way. Kilometer after kilometer, second after second, it approaches its date with Jupiter. A date that, according to all calculations, will occur with a precision that defies probability. The gas giant awaits it with its court of moons, its centuries-old storms, its own mysteries that we are barely beginning to unravel. And at the edge of its sphere of gravitational influence, on that invisible boundary where its domain ends and the sun's begins, the interstellar visitor will pass grazing so close it could almost touch it, so far it will never be captured. Unless, of course, something stays behind.
That is the million-dollar question, is it not? What will 3I/Atlas leave in its passage by Jupiter? Something tangible, something we can detect and study? Or just questions, more questions, one mystery on top of another? The coming months will give us the answer, and I promise you I will be here with you to tell you everything we discover.
Modern astronomy has its roots in the ancestral curiosity of looking upward. Since the first hominid raised its gaze and wondered what those little lights in the night sky were, our species has been fascinated by the mysteries of the cosmos. We have built temples aligned with the stars. We have created calendars based on the cycles of the moon. We have sent probes to the edges of the solar system and telescopes to the depths of space. All of that, millennia of effort and discovery, has brought us here, to this moment when an object come from the stars defies everything we thought we knew. 3. I/Atlas is not just a point of light in the telescopes. It is a mirror that reflects our limitations and our aspirations. It shows us how much we have learned, but also how much we have yet to understand. It reminds us that the universe is vast, mysterious, possibly inhabited by intelligences we can never imagine. And that, far from being terrifying, is profoundly inspiring, because it means there are still frontiers to explore, there are still discoveries to make, there are still questions we do not even know how to formulate, whose answers will transform our understanding of reality. 3. I/Atlas is an invitation to look beyond the known, to question the established, to keep our minds open to possibilities that defy imagination. And while the visitor continues its journey through our solar system, while the telescopes follow it and scientists analyze its data, we down here can do something simple but powerful. Look up, look at the stars, wonder what is out there. And remember that in this infinite universe, the greatest mysteries are also the most precious gifts.
Well, friends, we have reached the end of this journey, but before I say goodbye, I want to ask you one last question. Of everything we have talked about tonight, what part resonated with you the most? What moment in this story made you think of something from your own life? Perhaps a night when you looked at the stars as a child? Perhaps a conversation about the universe with someone dear to you? I would love for you to share it in the comments.
The story of 3 I/Atlas will continue to be written in the coming months and years. Each observation will add a paragraph. Each analysis will complete a sentence. And when the visitor finally disappears again into the interstellar darkness, we will have learned something even if we do not yet know what. Perhaps we will have discovered that comets can form in ways we never imagined. Perhaps we will have found new laws of physics that explain the observed anomalies. Or perhaps, just perhaps, we will have taken the first step toward recognizing that there are others out there, navigating among the stars, observing us from unimaginable distances. Whatever the outcome, it will have been worth paying attention. It will have been worth wondering, marveling, keeping alive that curiosity that makes us human, because in the end, that is what defines us, not the answers we find, but the questions we dare to ask. And 3 I/Atlas has given us a question we will remember for generations.
Felipe Suarez here, thanking you as always for joining me on this journey through the cosmos. If you liked this story, if it made you think, if it made you dream even just a little bit, I ask you from my heart to subscribe to the channel. And if you have a moment, leave me a comment telling me which part of the story touched your heart. See you next time. Take good care of yourselves and keep looking at the stars.
The night sky remains there, waiting, with its billions of stars, each one possibly surrounded by planets, each planet possibly harboring its own mysteries. 3 I/Atlas is just one of those mysteries, a point of light crossing our field of vision for a cosmic instant. But that instant is enough to remind us of our smallness and our greatness, enough to invite us to dream of what might lie beyond, enough to keep alive the flame of curiosity that has guided humanity since its first steps on Earth. The interstellar visitor continues on its path, we continue on ours, and somewhere between both trajectories, in that space where questions meet possibilities, the universe keeps its deepest secrets, waiting perhaps for whoever has the courage to discover them, waiting perhaps for us.